We present EgoLines, an interactive visualization that supports the egocentric analysis of dynamic networks. Imagine you want to use your egocentric approach to investigate how academic collaborations of an author change year over year. In this case, nodes are authors, and edges show co-authorship. For our analysis, we will focus on the collaborations between a focal author, their co-authors, and their co-authors' co-authors. EgoLines represents each author as a line across time steps, and uses a packing algorithm to tightly arrange them around the focal author, in this case, JF. Dashed lines indicate an author's temporary absence from the network for a given time step. Author line colors can encode a variety of node attributes, or network metrics. Here, the color indicates an author's membership in a cluster with other authors who share many co-authorships. Clusters can change over time. These transitions are illustrated using color gradients. Within each time step, network topology is shown using a layout akin to an adjacency matrix. Circles represent individual co-authorships. Here, we see JF collaborated with NB in 2010. Now that we understand EgoLines, let's explore the entire dynamic ego network of JF at all time steps. Overall, we can observe that the network constantly grows in size over time. But we're interested in JF's more recent collaborations, so let's filter out the earlier years. By revealing a boundary around JF's co-authors, we see that the recent growth in JF's network can be attributed to JF's co-authors' increasing collaborations. He is part of a thriving and expanding research community. But this community is not static. For example, FC, a co-author, left JF's network in 2010 for 2 years, only to rejoin as a co-authors collaborator in 2013. Meanwhile, another co-author, PI, has collaborated directly with JF every year except 2012. So who has had the longest collaborating relationship with JF? Switching to an unpacked view, we quickly identify that these authors are AB and PD. Is there much turnover of authors in the network? Filtering authors with relationships over 2 years, we see that there are a number of authors who are part of the network for a short time. Another aspect we can investigate is how clusters of co-authors change over time. For example, there seems to be an interesting change from 2011 to 2012. We can sort authors by their cluster membership. The green cluster in 2011 disappears in 2012, indicating these authors did not continue working closely together. One author, JW, merged into the purple cluster in 2012, indicating they worked more closely with a different group. As networks grow in size, so does the complexity of their relationship. JF's network is the largest in 2014. Hovering over an author reveals the shortest path back to the focal author. For example, RC is connected to JF through EB. By examining several co-authors in both green and red clusters, we find that many of them connect to JF through EB. This suggests that EB might act as a bridge between clusters in the network. But how can we confirm this hypothesis? By sorting co-authors by cluster within this year, we can clearly see that EB had many connections across the orange, green, and red clusters. Recall that we can display different metrics in the author lines. For example, by switching to display in nodes between this centrality, we can also confirm EB's role as a bridge. In fact, EB has a stronger score than the focal author JF, meaning that EB is a larger hub for collaborations. EgoLines is implemented as part of a complete visualization system that also supports high-level exploration tasks with an overview of the entire dataset, as well as a table view summarizing each ego network within the dataset. Thus, a user can explore any ego network of interest using EgoLines, while simultaneously browsing the context of the selected ego network in the entire network.